Hello, my name is Mauricio Barriga. The objective of this project is make use of integral calculus to find the area in a painting we did in our Spanish class. Hope you enjoy it and learn from it.
Hello, my name is Alejandro Charur, and today we're going to present to you the second part of our integrating project of areas and also integrals. And this project is formed by our Spanish class and also our integral calculus class of math of 6th semester. Hello, my name is Alejandro Charur, and on this part we're going to show you how basically we started our process to get our new equation, and basically we're going to start to show you what was the first part of our solution. Well, basically we started using the left endpoint approximation, and it was that basically we had the rule of using minimum 10 points. So basically we used the curves of our stripes in a area of from 2 to 4 on our x scale, and we used 10 points that were easy points that we could easily substitute in our xy table. Then, after already identifying our points, we used the application that is called Graphmatica. So we went now to our application, and basically we used our xy table, and what we did was basically copy the points we already got and basically putting them here so we can get our area under the curve, and it can be marked as if it is here in our graph. Basically we used our points, then we got the selection of curve fit, and then we already got our curve. That is basically the curve fit is like the meaning of getting the area under the curve, as we can see here labeled on our graph here in Graphmatica. So then we basically got our equation that here is shown labeled in our application, and this is basically the equation we're going to use to get our antiderivative. And so basically this equation, we're gonna get the integral of it, and basically getting the integral of it, then we're gonna do a process of substitution by using b minus a, substituting on the x value, and after that we are really gonna get our final answer. That is gonna be the one that is gonna be compared with our part 1 of this project, our centimeters squared and our units, and so we're gonna compare the two types of answers that we made us in part 1 and what we are gonna solve in part 2. Thank you.
After getting the formula that Alejandro Charur, my friend, helped us get, we need to derive this formula in order to continue the process. I'm going to show you how we did it. Here we have the formula that Alejandro gave us. We know that our intervals are between 2 and 4. This is from part 1, where we decided the length of the area under the curve we're gonna get. So in order to get this, we need to derive this first formula. When we derive it, it's very simple. You need to add 1 to the power of x and divide by the same number, and we did this in all of the parts including the last one. So we get this formula. We use the antiderivative symbol here, and we put the intervals 2 to 4 because, like I said before, to continue the process we need to enter the b of the formula to the first, and then subtract it with the a, which is the 2 in this case. So we use this formula with the 4, making the change of, we're gonna change the x in all the formula with the 4 because it's the first number we're gonna use because it's a bigger one. So we have this formula, instead of the x we have the 4. We did this, and we're gonna subtract with the same formula, but instead of the x, we're gonna have the 2. After setting this in the calculator and subtracting it with this, we get this number. The first 5.063 is from the first one, minus 0.3679 from the second one, give us 4.6950933, which is a unit squared because it's an area. And since our Cartesian plate is in centimeters, we change the units to centimeters squared. So our final answer is 4.6950933 centimeters squares. Thank you very much. As a conclusion and to compare the part 1 and the part 2 of our projects, we decided to show you how in part 1 we got, as a result of the process, 4.8845 centimeters squared, and in part 2, which is the part we just showed you how to do, we got 4.6950, which is not the exact number, but considering it's a painting made by us with not perfectly curved and with estimations for the part 1, even though part 2 is more exact, we can see how the numbers are really close, and this shows us that our estimation and our process is correct, because if the numbers were to be very different and apart from each other, this would be wrong. But since they are close, we can conclude that our process is good and we did it correctly, so we're happy about it and hope you enjoyed it. Thank you.
Well, to conclude our project, we have basically, I wanted to make a commentary that was the conclusion was that this project, as the same as part 1 and part 2, basically both of them help us a lot to get, to compare both answers with using the same integrals and using the same integral calculus tools, but basically used in different ways and used in different theories. And basically I wanted just to say that this project helped us a lot to get get more calculus knowledge and get more integral calculus theories, and how we can get same answers but with different theories and with different ways of process, some short and some longer, but this gave us a lot of calculus knowledge. Thank you very much.
Well, to conclude this project, I really want to say how much we learned showing different processes to get the same answer. Maybe some are more specific, some are more of an approximation, and some are more exact, but different processes give you the same answer. Some are larger, are longer, and some are shorter, but I really appreciate how we learn maybe the process that help us and fit us best, and maybe now we can choose when we want to do this in real life. I really liked how we combine the Spanish class with math class, because we are analyzing our same project, and this makes it fun and interesting, and it helped us in different ways to see how we can really use this in real life and learn from it. Thank you.